Okay, so this is part 3 of chapter 5, lesson 5 on access controls. And in this part, we'll talk about policies and procedures for accountability. So there are several different policies and procedures that we could use. Log files, these are a key ingredient to accountability. They are records that detail who logged into the system, when they logged in, and what information or resources they used. They may also detail where they logged in. Monitoring and reviews. One of the main reasons to track user access is to detect questionable actions and respond to them. You should use software that monitors your activity logs and generates alerts when it finds suspicious activity. Continuous monitoring is an important part of a secure access system. Reviews of user actions over time help detect policy violations and validate that user access definitions are correct. Data retention, media disposal, and compliance requirements. Most current laws require that organizations take measures to secure many types of data as well as how to dispose of media. Media disposal requirements. And not it's not always necessary that you physically destroy media. A degausser creates magnetic field that erases data from magnetic storage media. Once data goes through a degausser, it cannot be recovered. Another method is overwriting the data. This process works well if the amount of data to be overwritten is fairly small and the overwriting is fairly fast. Now, here are four formal models of access control. Discretionary, these are important definitions, by the way. Discretionary access control, or DAC. Here, the owner of the resource decides who gets in and changes permissions as needed. The owner can give that job to others. MAC, mandatory access control. The permission to access a system or any resource is determined by the sensitivity of the resource and the security level of the subject. It cannot be given to someone else. This makes MAC stronger than DAC. Non-discretionary access control. This is closely monitored by the security administrator, not the system administrator. Presuming you have a security administrator, but in any case, that's who monitors it. And rule-based access control. A list of rules maintained by the data owner determines which users have access to the objects. So talking about discretionary access control. Operating systems-based discretionary access control policy considerations. The access control method. Today's operating systems contain access control settings for individual users, rule-based, or groups of users, role-based. Which method you use depends on the size of the organization and the way specific access rights need to be arranged for individuals or roles. New user registration. When new users are brought into an organization, their accounts must be created. User registration must be standardized, efficient, and accurate. Periodic review. Over time, users can get special permission to complete a particular project or perform a special task. These need to be reviewed from time to time to make sure they stop when they are no longer needed. Application-based discretionary access control. This denies access based on context or content. Application presents only options that are authorized for the current user. For example, an automatic teller machine menu limits access by displaying only the options that are available to a particular user. And permission levels. We'll talk about these in detail on the next slide. User base. Permissions are granted to a user are often specific to that user. Job-based, group-based, or role-based. Role-based is called RBAC. Permissions are based on a common set of permissions for all people in the same or similar job roles. Project-based. Access is granted to people explicitly working on that project. And finally, task-based. This limits a person to executing certain functions and often enforces mutual exclusivity. If a person executes one part of a task, he or she might not be allowed to execute another related part of the task. It's based on the concepts of separation of duties and need to know. Mandatory access control. This determines the level of restriction by how sensitive the resource is, its classification label. The system and owner make the decision to allow access. Something called temporal isolation or time of day restrictions. This restricts access to specific times. It first classifies the sensitivity level of the objects, then it allows access to those objects only at certain times. It's often used in combination with role-based access control. Mandatory access control is stronger than discretionary access control. Now, non-discretionary access control. The access rules are closely managed by the security administrator, not the system owner or ordinary users. Sensitive files are write protected for integrity and readable only by authorized users. It is more secure than discretionary access control, ensures that system security is enforced and tamper-proof. Now here we have a rule-based, not role, but rule-based access controls, where explicit rules grant access. This comes out of the textbook. We have 3 users, Jane, Fred, Albert. 3 applications, customer service, inventory, and accounting. Access is based on a list of rules that determine who should be granted access. Data owners make or allow the rules. They specify privileges granted to users, such as read, write, or execute. The success of this method depends on the level of trust you have with the data owners. This type of access pushes much of the administration down to the data owners. So here we have Jane. A rule grants her access to customer service, to inventory, and to accounting. Fred, Fred has access only to inventory and accounting, and Albert has access to customer service and accounting. Now, access control lists. So in Linux and OS X, the permissions are read, write, and execute, and they're applied to file owners, groups, and global users. In Windows, Windows has both share permissions and security permissions, both of which enable access control lists to define access rules. Share permissions are used to get to resources by a network share. Security permissions are used to get to resources when the user is logged on locally. Some share permissions, as it says here, include full, change, read, and deny. Some security permissions include full, modify, list of folder contents, read, execute, read, write, special, and deny. In both share and security permissions, deny overrides every other permission. So what happens if no access control list exists for a resource? Most authorization systems use implicit deny, which means that if no rule to grant access exists, access is automatically denied. This approach is more restrictive, but much more secure. Okay, so here's an access control list where Hal has full control over the user Hal directory. User Kevin directory is he could write to it. User Kara directory, no access, and printer 001, execute. And you can see user Hal directory for Kevin, he could write to it. User Kevin directory, full control, no access to Kara, no access to the printer. Kara, for the user Hal directory, she can write to it. She has full control over Kevin, so she must be a supervisor or something. No access to her own directory, which is kind of weird. And she can execute printer 001 and printer 002. I'm not sure if I would give myself no access to my directory. I don't understand that. But this comes straight out of the textbook, so I didn't make it up, but I just don't understand that part. Okay, so role-based access control. You have implicit rules grant access, but here Jane, Fred, and Albert have the customer service agent role, which allows them into these different applications. Now, before you assign access rules to a role, you must define and describe the roles in your organization. The process of defining roles, approvals, role hierarchies, and constraints is called role engineering. Starting with a clear list of role definitions that fit your organization is the key to RBAC. The real benefit of RBAC over other methods is its ability to represent the structure of the organization and force compliance with control policies throughout it. So that's the biggest benefit of RBAC. is to represent the structure of the organization and enforce the compliance with the control policies throughout it. So suppose Jane and Fred should have access to the inventory application, but Albert should not. Looks like he does, but as shown in the figure, Albert does have access to the application. Well, he does, which is a need-to-know violation. This error is due to overgeneralizing of rules. This can provide more access to individuals than was intended. When you assign roles, consider creating one role for every user or one role for a very small number of users. Content-dependent access control. Based on the values in the data, the local manager here can see data on the employees in the same department, but the human resource manager can see data off the payroll server on everybody. And that's dependent on values in the data itself and who you are and what role you have. But it's dependent on the content. A constrained user interface. Now, this is something that I've actually talked about on tests, on homework assignments. But in any case, these are methods of constraining users from doing something we don't want them to do. Menus simply don't give users any idea that the data or programs exist. When they log on, they don't see what they cannot access. A good example of this is the IBM menus that I was in charge of as the project manager for all purchasing and inventory control at Savannah Foods and Industries. If a person didn't need access to a particular program, the menus would show up with like 24 options. So if a person did not need access to a particular option, they didn't see it. They would log in and they might see options 1, 2, 3, 4, which are different programs, but not 5, 6, and 7. And then they would see 8, 9, and 10, and 11, and 12, and so forth. So you would not show a particular, and IBM was very good at this, at allowing somebody in charge to determine what options a person could see, and you would just configure it so that based on who that person is, they would not be able to see certain menu options, and thus they couldn't do that function. Database views, or view-based access control, VBAC. This approach is often used with relational databases. The database system creates a view for each user that limits data he or she is able to see. Partitioning a database into slices is called multi-tenancy and allows different groups of users to access a database without being able to access each other's data. Physically constrained. User interface mechanism presents the user with a limited number of options, such as an ATM with a limited number of buttons to push. It's different than a menu because the menu is logical sitting on a screen, but a physical button is something that you're not allowed to push on an ATM, or you are. And encryption. This constrains users because it requires them to have the decryption key to reach or read information stored on the system. It also hides information from the user. Here's some other access control models that some of them are rather well known. The Bell-LaPadula model focuses on confidentiality of data and control of access to classified information. Parts of the system are divided into subjects and objects, and the current condition of a system is described as a state. The model defines a secure state. The model guarantees that each state transition preserves security by moving from a secure state to a secure state. It's built on the concept of a state machine that features a set of allowable states in a computer network system. The transitions are defined by transition functions. The BIBA integrity model. This fixed a weakness in Bell-LaPadula, which addressed only confidentiality of data. This consists of 3 parts. A subject cannot read objects that have a lower level of integrity than the subject does. So you can't read objects that have a lower integrity level than you have. A subject at a given integrity level can read only objects at the same integrity level or higher. This is known as the simple integrity axiom. The second part says the subject cannot change objects that have a higher level. So that's the second part of that of the BIBA integrity model. And the third part says the subject may not ask for service from subjects that have a higher integrity level. Subject at a given integrity level can call up only a subject at the same integrity level or lower. Clark and Wilson. This focuses on what happens when users allowed into a system try to do things they're not allowed to do. It looks at internal integrity threats, addresses 3 integrity goals. It stops unauthorized users, from making changes, stops authorized users from making improper changes, and keeps internal and external consistency. And Brewer and Nash, this was built based on a mathematical theory published in 1989 to ensure fair competition. It is used to apply dynamically changing access permissions. It can separate competitors' data within the same integrated database to make sure users don't make fraudulent changes to objects that belong to a competing organization. So here in the Brewer-Nash integrity model, we have the Bank of Norwich, the Bank of Gloucester, and a rule. So in this example, an auditor who worked on data related to the Bank of Gloucester is prohibited to getting to any data belonging to the Bank of Norwich, which is off limits due to a conflict of interest. And this concludes part 3. In part 4, we'll talk about the effects of access control as well as threats to access control.